To understand the significance of this shift, we must look back to 1856. A young chemist named William Henry Perkin, while attempting to synthesize quinine, accidentally created a vibrant purple dye he called Mauveine. This was the world's first synthetic dye. It triggered an industrial explosion. For the first time, color was cheap, consistent, and available on an unprecedented scale. This efficiency, however, came with a hidden system-level cost. The industry became heavily reliant on petrochemicals, and the effluent from dyeing facilities, filled with azo dyes and heavy metals, became a primary source of water pollution in manufacturing regions. The problem wasn't the color, it was the engine driving it. The alternative has existed for millennia. Ancient civilizations were master color chemists, extracting vibrant hues from the world around them. The Phoenicians created the legendary Tyrian purple from sea snails, a color so expensive it was reserved for royalty. The Aztecs harvested cochineal insects from cacti to produce a brilliant crimson, a commodity once more valuable than gold. Indigo from the Indigofera plant created deep blues that defined an era of workwear. This wasn't a simple process. It was a craft of immense skill, a deep understanding of botany, chemistry, and materials. It represented the original definition of luxury, color derived from a rare and valuable source through a mastery of process. Today, the revolution isn't about reverting to ancient, small-scale methods. It's about applying 21st century technology to this ancient knowledge base. Modern science is solving the historical inefficiencies of natural dyes. Researchers are using enzymatic treatments to help fabrics bond with dyes more effectively, drastically reducing the need for toxic mordants. Ultrasonic-assisted extraction can increase the yield of pigment from plant materials, making the process far more resource-efficient. We are even seeing the rise of Bio-Fabrication, where microorganisms like bacteria are genetically programmed to produce specific pigments in a lab, a process that consumes minimal water and can be powered by agricultural waste. This transforms natural dyeing from a craft into a scalable, high-tech manufacturing process. From a strategic business perspective, this shift is a powerful tool for differentiation. In a saturated market, a product colored with dyes derived from avocado pits or onion skins has a verifiable, data-driven story. It offers a unique value proposition that justifies a premium price point and appeals directly to a consumer base that is increasingly skeptical of vague, eco-friendly claims. It is no longer just about aesthetics, it's about authenticity. The color becomes a tangible data point in a transparent supply chain, a signal of a brand's commitment to moving beyond the limitations of a 20th century industrial model. This is how quality is communicated in the modern marketplace. However, the path to mass adoption still presents significant engineering challenges. The three primary hurdles are often cited as cost, consistency, and color fastness. The inherent variability of natural materials means that achieving a perfectly uniform color across millions of garments is exponentially more complex than using a standardized synthetic formula. Furthermore, ensuring that these colors withstand UV light and repeated washing at an industrial standard requires further innovation in fixation technologies. These are not insurmountable barriers, but complex system-level problems that require investment in process optimization, automation, and material science. Solving them is the next frontier for this colorful revolution. The future of color is not a simple choice between the synthetic and the natural. It's about a new synthesis, leveraging technology to unlock the potential of nature at scale. It's about building a more resilient, transparent, and valuable textile industry from the ground up. The revolution is in applying our most advanced knowledge to our most ancient sources of color. Speaking of ancient sources, our next deep dive will explore a fiber that has been with humanity for over 30,000 years, a symbol of durability and understated luxury. Join us as we analyze the system behind linen.